All right, guys, since we will not necessarily get to all these problems in class, I do want to just make sure that I've at least talked about them. I'm not going to work every single one of them out, but I will, post the solutions. But the first thing I want to do is take a minute and just kind of differentiate between the problem types. So 27 through 36 are definitely composition. You're composing functions, so you're going to find the input of one function, or you're going to evaluate a function, so you're going to plug a number into the inner function, find the output, and then plug that into the outer function. So you're composing. All of these are composing except the last six. The last six are practice for the last video, which are cotangent, cosecant, and secant inverses. Okay, which we're going to cover minimally. There are only a couple cotangent values that you really need to know on the unit circle. Same thing with cosecant and secant. Okay, so those are our reciprocal functions. We're thinking of cotangent inverse like we did tangent. We're thinking of cosecant inverse in terms of sine inverse, and secant inverse in terms of secant inverse. So I'll kind of hold off till the end on those. Those are just that's kind of a different process. All of the others, let me put a kind of blue boundary. So the blue boundary problems are definitely composition functions. That's what you're going to see for the most part on the quiz. Most of it's going to be composition. A little bit of just find the value of one inverse function. So there will be a little bit of this for sine, cosine, tangent, cotangent, cosecant, and secant inverse functions. But most of it will be composition. So let's differentiate. I'm going to look at each one of these composition problems, and before you even start the quiz, kind of sort your thoughts. Tangent inverse of 1/2, that is not a unit circle problem. When I think of tangent of an angle, I don't think of 1/2. Sine, root 2 over 3, not a unit circle problem. So we'll work that. Sine inverse negative root 2 over 3. So far, I don't see any unit circle problems. Tan inverse, tangent inverse. Cosine of an angle gives me root 3 over 3. Nope. Definitely not. Nope. Then I get to the end and I see, okay, cosine of 3 pi over 4. This one's going to be just a unit circle problem. This one's also sine of an angle that's on the unit circle. That's a unit circle problem. So all of the rest, let me circle them. So all of the ones that I'm underlining in a light kind of grayscale, all of these are going to be the XYR problem, being careful to know if X is negative or if Y is negative. That tells you which quadrant you're in. So there's that logic going on. So we have 27 through 34 are basically one type of problem. Find X, find Y, find R, and then find secant of theta, find cosine of theta, find cotangent of theta. So I'll work a couple of those. I'll go ahead and blast through 35 and 36. And then I'll just kind of work a couple of, so I'll work a cotangent problem. I'll work a cosecant problem, cosecant inverse. And I'll work a secant problem. This one looks like the one we did in class, so let me do this one. Okay, and I'll post the solutions. So just know 27 through 34, exact same process. 35, 36, same process. 37 and 38, same function. 39 and 40, same function. So your way of thinking about these two problems is the same. And then 41 through 42. So before you start a quiz or a test, you really should take a minute, look at it, kind of sort out problem types, right? So to me, that just kind of, okay, I know this type of problem. You just kind of sort your thoughts. Then when you start, you're like, okay, I'm ready for this thing. And then you just start chipping away at it one problem at a time. So I'm going to pick a couple problems that I think are a little bit more challenging. Tangent inverse of 1 over 2. Okay, well, that's my y value. That's my x value. That's in the first quadrant. So not very interesting. So I'm going to kind of skip that one. I'm going to do what I think are more challenging problems. 30 and 31, you have tan inverse of a negative value. I'm going to do 30. So 30 and 31 are kind of equal in difficulty. I think 30 is more difficult because then you evaluate sine. We're more comfortable with sine than we are cosecant. So 30 is a good one to do. So I'm going to start with 30. Let's look at a couple more of these. I definitely want to deal with when the input is negative. So I'm going to do 30. I'm going to do 29. Sine inverse of a negative, then cotangent. So that one's going to be interesting. Cosine inverse of a negative value, and then cotangent. So these are going to help me sort out what's the range of tangent, where's theta live, what's the range of sine inverse, where does theta live, etc. So I'm going to do 30, 29, 32. I'll knock out both of these, and then I'll do 37, 40, 42. All right, so let's go. So let me move this over a little bit if I can. It's moving slowly. All right, so I'm going to work number 30, which is, so we have cosecant of tangent inverse of negative 2. Okay, you can use brackets, parentheses, however you want to write that. So here's what I know off to the side. Tangent theta equals negative 2. Tangent really is a ratio, so the output is a ratio, so I can put that over 1. This is my y value. This is my x value. I know that tangent inverse lives in the first or fourth quadrant. If the input of tangent inverse is negative, that means the angle's going to be in the fourth quadrant. If this tangent inverse is positive, I'm in the first quadrant. So this tells me that y is negative 2 and that x is positive 1. I'm going to draw my triangle, remember? There's my r value, and then this is where some mistakes happened way back in the past. Never connect to the y-axis when you draw your triangle. Always connect that point. Remember, that's the point 1, negative 2. Always connect the triangle to the x-axis. So I know if you want to label the triangle, the side length is 2, even though the y value is negative 2. The x-coordinate is 1, which means the side length is 1. And then I need to find r. Okay? So this helps me build my diagram. The input will always give me of x, y, and r. The input is going to give me 2 of those 3 values. So my y value is negative 2. My x value is 1. I can find r. So the problem is cosecant of this, and of this is going to help me find all the values I need. That's going to equal cosecant of, we called this theta. So now we're finding cosecant of theta. Okay, so the original problem equals cosecant of theta, which equals, now what's cosecant? So let's kind of define that off to the side. Sine of theta is y over r. Therefore, cosecant of theta is r over y. So because I'm finding cosecant of theta, the problem is basically find r, find y, build a fraction. Okay, so as soon as I find r and y, I can build this answer. So my answer is going to be, I don't know what r is yet, over negative 2. So let's find r. Pythagorean theorem. So the x value is 1. 1 squared is 1. Negative 2 squared is positive 4. You've got to be careful. X squared, always positive, or 0, but in this case it's positive. Y squared is negative 2 times negative 2, which is 4. So r squared is 5. So r has two solutions, but only one of which makes sense. So my r value is the square root of 5. Okay? So here's my final answer. You can write it like this, and I genuinely hope Delta Math isn't so picky, but we're kind of doing these by hand. So either one of those, perfectly okay. All right, so that's number 30. All right, so there's number 30 in all its glory. On to number 29. Okay, so number 29, very similar, exact same process. So I'm going to work a little bit faster, and then I'll go to the next problem. All right, so first step, we're going to call sine inverse of whatever. We're going to call it theta. And then cotangent by definition is x over y. So I want you to see big picture before we get lost in the details. Cotangent of something, and that something is an angle. Cotangent of that angle by definition is x over y. So when we're done, the answer is just going to be the x coordinate over the y coordinate. But we have to use the given information to determine that. So off to the side. So we want to find this first. Anytime you're given a fraction that's negative, I always think of the numerator as being negative. So sine of what angle gives me negative root 2 over 3. So far, I know sine by definition is the y value. So I know my y value is negative. It's going to take me down. My r value, so remember this is y over r by definition. It's important to know sine inverse lives in the first quadrant or the fourth quadrant, not here, not here. And because y is negative, my y value is going to take me down. So negative 1 is there. Just so you know, the square root of 2 is 1.4-ish. So if that's negative 1 and that's negative 2, I'm about here. My y value is 3, so I'm going to bring the y value out to here. I'm going to draw my triangle. So my r value is 3. The height of my triangle, so remember this is negative root 2 about here. So I'm going to call this root 2. So I need to find my x value. And then I look, okay, do I need my x value to answer cotangent? Yes. If I didn't need my x value, I can just answer the problem. So you'll always, once again, be given 2 of the 3 values indirectly, and then look at where you're going before you even do all the work. So I know Pythagorean theorem. Equals r squared. So I don't know r squared. I don't know x squared. Negative square root of 2 squared, negative square root of 2 times negative square root of 2 is positive 2. 3 squared is 9. Subtract 2. X is plus or minus the square root of 7. But since we are in the fourth quadrant, my x value has to be positive root 7. So my answer is the square root of 7 over negative square root of 2. Rationalize like always. So that's going to give me square root of 7 times the square root of 2 is the square root of 14. Square root of 2 times the square root of 2 is 2. And the negative really doesn't matter where you put it. I tend to put it in the numerator or think of it as the opposite of a fraction. Really, it could be root 14 over negative 2. Middle school teachers do not like that. They get very upset about those rules. Can't have a negative in the denominator. Sure you can. Okay, so that takes us through number 29. My hope is you start to see, okay, I see the pattern. I'm given 2 of the 3 values. Be careful, know where the inverse function lives so that you know the signs are correct for x, y, and r, and then finish evaluating. On to the next. All right, number 32, cotangent of cosine inverse of negative root 3 over 3. So let's kind of unwind this one as well. Cotangent of this, which I'm going to call theta. Cotangent again is x over y. So the outer function, you kind of know where you're going. Cotangent of something. So cosine inverse, and once again, I'm being very intentional about choosing these problems. I wanted the input here to be negative. Cosine of some angle equals negative root 3 over 3. So I was intentional. Cosine inverse lives in the first or second quadrant. Because the input is negative, that tells me that the x value, cosine by definition is x over r. X is negative root 3. That means I'm moving to the left, so I have to be in the second quadrant. So negative 1, negative 2. Root 3 is about 1.7, so negative root 3 is about negative 1.7. My r value is 3, so so there's negative 3, so I need to make that about there. So I have r is 3. My x, the length of the base is root 3, which is about 1.7. I don't know y yet, but I'll find it. I need y to find cotangent. So, Pythagorean theorem. X squared plus y squared equals r squared. Don't forget, drop your theta in there. I'm not being picky about theta. You know the triangle is in the second quadrant. That's what's most important. But this angle is the reference of theta. Theta is starting on the x-axis and swinging into the second quadrant. So x squared, negative root 3 times negative root 3 is positive 3. 3 times 3 is 9. So y squared equals 6. Y is the square root of 6 plus or minus. I know it has to be the positive one. So our final answer is, and once again, I'm working these faster. Take your time. Don't make mistakes like I love to do. So x is negative root 3. Y is root 6. So you rationalize, and you get negative root 18 over, and we could have simplified this before, but that's okay. Let's work this out. Root 18 must be simplified. There's a perfect square factor hiding in 18. It needs to come out. 3 root 2. So this is negative 3 root 2 over 6, which is 3 over 6. Reduces to 1/2. Final answer. So really, we could have done that here. When you have a radical divided by a radical, it is 1 radical. Okay? There's a property that says root a over root b equals root a over b. Right? The quotient of the roots is equal to the quotient, the root of the quotient. Fancy language. All right, so we could have simplified this to 1/2 first, and then what's the square root of 1? It's 1. What's the square root of 2? I don't know. And then you rationalize, and you get the same answer. I think this route is clearer, but you can also go this route. Either way, you're going to get the same answer. Regardless, when you wind up rationalizing and you have root 18, if that had been root 17, done. But root 18, you need to simplify. All right. So 27, through 34 are all virtually the same type problem. I did 3 of them. Knock out the other 1, 2, 3, 4, 5. Check your solutions. I'll post my solutions. Now I'm going to knock out 35 and 36 right here in this space. 35 and 36 are straight unit circle problems. So number 35. Number 35 is sine inverse of cosine of 3 pi over 4. All right, so this becomes sine inverse of something. Cosine of 3 pi over 4, 3 pi over 4, has an x-coordinate of negative root 2 over 2. So this becomes sine inverse of negative root 2 over 2. Then the question is that, now here's where you got to be careful. Sine inverse lives in either the first quadrant or the fourth quadrant, but the input is negative root 2 over 2. So I'm thinking sine of what angle gives me negative root 2 over 2. That angle has to be a negative angle to give me a y-coordinate of negative root 2 over 2. That angle has to be negative pi over 4. Okay? So you evaluate cosine of 3 pi over 4. Then you ask yourself, what angle for sine gives me out that y value? But be careful, sine inverse lives in the first, fourth, not second, third. All right, that takes us to number 36. So number 36 is find cosine inverse of sine of 7 pi over 6. So the first problem is just a unit circle problem. 7 pi over 6 takes me slightly into the third quadrant on the unit circle. And those coordinates are negative root 3 over 2, negative 1/2. So sine of 7 pi over 6 has a y-coordinate of negative 1/2. So now I'm thinking, once again, cosine inverse. Cosine of what angle gives me out negative 1/2? So to be careful. So cosine inverse lives between 0 and pi, so there's less room for mistakes with cosine inverse. My x-coordinate is negative 1/2. So when my x value is negative 1/2, the question is, what is the angle that gives me an x-coordinate of negative 1/2? And that angle is 2 pi over 3. So the final answer is, that angle is 2 pi over 3. So cosine inverse of negative 1/2 is 2 pi over 3. Not negative. So cosine inverse will never have a negative angle. Cosine inverse will always come out between 0 and pi. Okay? Very different than sine inverse and tangent inverse. All right. So we're through the first set of problems. All right, so let's knock out number 37. So number 37 is find cotangent inverse of root 3. What's the angle? Okay, so just to remind you, you need to know cotangent inverse lives between 0, not included, and pi, not included. So the question is, cotangent of what angle gives me out root 3? So remember, that's root 3 over 1. And where did that come from at this point? I keep saying at this point only because we've done these a lot. So this has to be, that's where root 3 comes from. We've seen for tangent and cotangent, every time our output of the original function is root 3, it comes from these coordinates. And cotangent by definition is x over y. So I know my x-coordinate is positive. My x-coordinate has to be root 3 over 2. And my y-coordinate has to be 1/2. The only angle in the first quadrant that gives me root 3 over 2 and 1/2 is pi over 6. So cotangent inverse of root 3. Ooh, I got excited, guys. My computer blew up on me. See if I can find the work. Hey, there it is. Flew up into space here. I don't know what happened. So, cotangent. Let's try that again. Oh, I missed writing on a board. Cotangent. Let's try it one more time. My computer is working overdrive to make a video while using the interactive whiteboard. So cotangent inverse of root 3 is pi over 6. Final answer. All right, our last two are cosecant and secant inverse. So just to remind you of process, right? I taught all the theory and the concept in the last video. Cosecant inverse, you have to think sine inverse. And then reciprocal. So the reciprocal of 1 over root 2, or the reciprocal of root 2 is 1 over root 2. I'm going to say it again. You get tired of hearing me say this. But we've seen this a lot. The reciprocal of root 2 is root 2 over 2. So then you're thinking, for sine inverse, what angle gives me out a y value of root 2 over 2? And that angle has to be pi over 4. Final answer. So just to recap, cosecant inverse in terms of evaluating is just evaluate sine inverse at the reciprocal value. Secant inverse, same concept. Secant inverse, you're going to evaluate cosine inverse at the reciprocal value. And the reciprocal of negative 2 is negative 1/2. So now, cosine inverse lives here. My x-coordinate is negative 1/2, and we've seen this earlier in the video. Where is my x-coordinate negative 1/2 on the unit circle? In the second quadrant, and that angle is 2 pi over 3. Final answer. So I want you to see that secant inverse becomes cosine inverse of the reciprocal. Cosecant inverse becomes sine inverse of the reciprocal, and so every cosecant inverse problem is a sine inverse problem. Every secant inverse problem is a cosine inverse problem. All right, guys, under 30 minutes. Quick recap of 27 through 42, the other solutions. So 27, 28, 31, 33, 34, 38, 39, 41. Those solutions will be posted as well, so check your work, but you should have everything you need to go forward and ace the quiz. All right, good luck, guys. Enjoy your weekend, knock out that quiz, and I'll see you guys Monday or Tuesday.